I'm a professor in the Department of Earth and Environmental Sciences at the University of Iowa. Primarily, I'm a vertebrate paleontologist, somebody who studies vertebrates, animals with a backbone, of the distant past as known in the fossil record. But I'm also a herpetologist, somebody who studies amphibians and reptiles, and a systematist, somebody who studies systematics, the field that includes everything from naming and describing new species to organizing those species into named groups, something often called taxonomy, and organizing those groups in ways that mean something, which these days is based on evolutionary relationships. Specifically, I study the diversity and evolutionary relationships of living and extinct crocodiliforms, modern alligators and crocodiles, and their close fossil relatives. My duties at the University of Iowa fall into three categories: teaching, service, and research. For teaching, I teach courses on vertebrate paleontology and evolution when classes are in session. I also work with graduate students who are working to become the next generation of vertebrate paleontologists. Service is a broad category, and it includes working on various committees that help run the university and set its policies. I also serve on committees within my professional organizations that represent and promote our field. Now, as for my research, I do sometimes go into the field to collect fossils. I've done this in places like Utah, West Texas, Alberta in Canada, Venezuela, and in Tanzania. But most of my work takes place in museum collections around the world. I visit museums and examine crocodiliform specimens, either from living species or as fossils. This means I make sketches, I take a lot of notes, I take a lot of photographs, and then I compare the information I've collected from one set of remains or one specimen with what I know about all others. The goal of my research is to essentially build a complete family tree for crocodiliforms, both living and extinct. Now, this family tree can then be used for all kinds of things. It can be used to understand how crocodiliform diversity changed over time, how it responded to things like climate change, why crocodiliforms survived catastrophes when many other groups went extinct, how crocodiliforms spread to where they lived in the past and where they live now, and how they adapted to a variety of habitats. Modern ones almost always live in freshwater, but some have lived in coastal oceanic waters. Others have lived less in the water and more on forest floors. How did they do that? I guess I started out as a dinosaur fanatic in first grade. Actually, a lot of my colleagues start the same way. But I was interested in all aspects of the natural sciences. I fell in love with dinosaurs, but I also watched astronauts walk on the moon when I was little. And that was a big inspiration. It still is. I also used to catch frogs, toads, and salamanders around my house in New England. And one day I came across a garter snake, a perfectly coiled eastern garter snake. It is to this day the most beautiful animal I've ever seen. And it cemented my interest in animals in general and reptiles in particular. Ever since then, I've really liked reptiles. Now, by the time I was in college, my interest had broadened in all of the earth and life sciences, and I explored several career paths. But I ended up really wanting to follow vertebrate paleontology as a career. To this day, I have no idea why I fell in love with crocodiliforms. I just did. That happened after I finished my bachelor's degree at the University of Iowa and had started graduate school at the University of Texas. I did end up working on a dinosaur for a time, the big Tyrannosaurus Rex at the Field Museum, Sue. I was hired to do the scientific work on it after I finished in Austin, but before I moved to the University of Iowa. I learned a lot about tyrannosaurs, but really I prefer crocodiliforms. For one thing, we don't need special effects to see crocodiliforms eat people. Now, another inspiration actually came from outside the sciences. My grandfather. My grandfather was a theater professor throughout his career. He worked at several universities, including Iowa. There was always something about the life he led as an academic that really appealed to me. So as well as being I always wanted to be a scientist, but I also always wanted to be a professor. In training in high school, I took as much science and math as I could, but I also took a lot of creative writing. I'll come back to that point in a minute. In college, I got a bachelor's degree in geology. About half of my colleagues did the same thing. They have their bachelor's degrees in geology. Historically, paleontology has been considered an earth science. But about half of my colleagues got their degrees instead in biology or maybe anthropology, because we also study living things that happen to be dead. It doesn't really matter which one you do as long as you take courses in all three. You have to be well-grounded in all three of those fields. Now, what's important to realize is that you don't want to just focus on science when you're in college, okay? It turns out when I think back on it, the most important courses for me were in things like literature and creative writing, because if you can't express what you did clearly in words, then there's no point in having done it at all. I also took courses in theater arts that I think improved my ability to teach. And I took courses in statistics, which turned out to be very important, not just because I learned statistical methods that I forget all the time and have to look up again, but because I learned how to think statistically. Okay, a lot of people say mathematics is the language of science, but for the kinds of science I do, really, it's statistics. You don't have to really learn all these statistical methods and techniques to think statistically. It's a matter of understanding how you set up an experiment, how many specimens or observations will you need. How do you assess the importance of any differences you find? What do the numbers mean after you've done everything? That's the crux of it all. And so I would encourage all of you to consider taking courses in statistics when they're available to learn how to think statistically. It's also, by the way, really important to learn how to use a camera. I have several favorite experiences. It's really hard to pick one. It's always a great thrill to see a specimen and realize it's a species new to science, something no one had ever realized before, even if they'd seen it. Now, the first time this happened for me was in the American Museum of Natural History in New York. This was back in the early 90s, and I looked at an extinct crocodile from Madagascar. This was something people thought was just a misshaped or odd-looking Nile crocodile, which is the species that occurs in Madagascar today. It was about the size of a Nile crocodile, but it had horns, and it had a really deep snout, and it just looked different. The closer I looked, the more I realized it wasn't related to the Nile crocodile at all. It was more closely related to the living dwarf crocodiles of West and Central Africa. These are really neat animals that never get bigger than about 5 or 6 feet, and that's a really big one. So I was looking literally at a giant dwarf crocodile. Now, more recently, my work in East Africa has led to all kinds of wonderful experiences. I get to meet with experts from around the world, including East African experts who really know their stuff. I get to work with especially paleoanthropologists. I've worked in the past with people studying dinosaurs. Now I work with people who study early humans and human origins. My animals ate their animals, literally. I've also been able to work in East Africa, which is beautiful. It's always a great experience. I've seen incredible wildlife. I've also seen some really famous fossils, including Lucy, which is one of the most important early humans ever found, and things like that. My advice would actually be to not specialize too early. If you think you want to be a paleontologist, I would suggest stop saying you want to be a paleontologist and start saying you want to be a scientist, and try to develop interest in all of the sciences. That's very important for a few reasons. First of all, the broader you are, the better a paleontologist you'll become if you decide to become a paleontologist. I think the future belongs to people who can bring together information from a variety of scientific disciplines in ways that nobody could have in the past. And the broader you are, the easier it is for you to do that. Secondly, you might actually find a career path you hadn't thought about that you like better. It's worth keeping your mind open because you might find something else that would be fruitful. And third, the year I got the job at the University of Iowa, there were more openings in the United States for governor than there were for vertebrate paleontologist. Jobs are very few and far between. I actually require my PhD students to take human anatomy in the medical school. That way, when they leave graduate school, if they can't find a job teaching vertebrate paleontology, they can find one teaching human anatomy. And they can still conduct paleontological research. They're still paleontologists, but their day job involves teaching human anatomy. So you want to keep broad for all of those reasons.